Now we will begin to talk about the IP access control list. Access control list first is a packet filtering technology. Of course, this technology also can be used when you do some root import. Okay, I will to reply one answer for the guys at the beginning. We can use the command show IP OSPF neighbor detail to check more detailed information of OSPF path. Okay. And about the access list, why we need this technology? Because maybe after we know the basic principle of OSPF, we already know how to forward the traffic within the same segment and also how to forward the traffic beyond to different segments, right? But now our requirement is if the routing is successfully and then we want to control some traffic. For example, to let the traffic cannot be forwarded out or not. And in this scenario, maybe we can use the ACL to do the control. And especially in the firewall, you will see we will deploy so many ACLs to control the traffic. And after taking this course, the first one we have to know the basic principle, how to work of the ACL and what's the configuration and some typical applications in our network and some key points we have to know when we do the deployment. The first one, let's say the working principle. Why we need the ACL? For example, now here is a topology. We have lots of access switch, distribute switch, and call switch, and lots of terminals within different segments. And we now give the basic configuration of VLAN and basic configuration of IP address and also add some static route or maybe dynamic route. And PC A, B, and C, they can directly wait with each other. But now our requirement is PC A can communicate with PC C, but PC A cannot communicate with PC B. So how to meet the requirement? Because according to the routing information, they can directly communicate with each other. But someone maybe say you can delete the route on the core router. That means if you don't have the router, this segment cannot do the communication with all the other one. So in this scenario, we need the ACL to do the control. And another scenario may be for this topology, for the security reason, it is required that employee's PC cannot access the supervisor's network segment. We have the employee 1 and 2 located in 192.168.1.10 segment and 3.10 segment, but we cannot reach the segment of 2.0 segment. All the traffic cannot work. So how to meet the requirement? As we know, if we delete the route, all the segments cannot wait this destination. So if you only want to control several traffic, in this scenario, you can use ACL. And about the ACL, we call the name is access control list. And we can define a series of different rules, and then we can control the traffic. And the inbound and outbound interface of devices, both of them can be used to deploy the ACL. And we can classify the packets according to the rules and the different process actions for different packets. And here we can divide it. Access can be used in two scenarios. The first one, we can use the ACL to control the traffic, especially for the traffic filtering. For example, they cannot communicate with each other or they can communicate with each other. This is the traffic filtering. And the second, later we will talk about the net address translation, NAT. You also can use the ACL to design some special IP address can be translated and then to visit some destination, but the other cannot. So this also is the control of the traffic. And the third one for the QoS, quality of service. And in your network, maybe the resources is not enough and you want to get more resources for some important traffic. So the first step, you also have to select which traffic you want to give the more resources. And how to select this traffic, we also can use ACL. And the second, we can match the route. And about the route means, for example, you do the route policy or do the routing distribution. And you also, for example, maybe in your routing table, you learn some segments from the RIP. You also learn some segments from the OSPF. You want to make the route routing information to become OSPF LSA and told your OSPF neighbor. So in this scenario, you also can use the ACL to select route. And about this process, the routing information will be matched on your IP routing table, not about the traffic. So we can divide the ACL in different application scenarios. This is the function. And another one is very important is ACA, access control entry. This is the detailed rule in the access list. And why, for example, which traffic can be controlled, how to limit the range, how to give the definition, depends on the entries you configure on the devices. So all the entry you have to configure one by one and meet your real requirement. And each rule on the ACL, we have the number ID kit. We have the number ID, and we will compare the rule from top to bottom, from the lowest to highest number, and compare one by one. At least one entry is matched, we will stop, and then to take the action and maybe for the traffic, maybe discard the traffic. So this is the entry. And pay attention about this part. After all the ACE, maybe your entry you only configure one, maybe you create 100. At the last, there is a default ACE, deny IP any, and when you use a command like show running, and you want to check the configuration of ACL, you cannot see this command, but this one located on your ACL. That's all. That means if you deploy the traffic on your interface, and when we receive the traffic, we will compare the entry step 1, 2, 3 seconds at the last. If all the traffic cannot be matched, all the entries cannot be matched, we will take the action is denied. So pay attention about this part. Maybe you also can use a command to change the action to become permit. And the action of the ACL, we only have two. One is permit and another one is deny. Permit means we will allow, or maybe this route is the route we want. And then the traffic can enter into the next step, maybe forward it out. Maybe we will send it to our neighbor. And deny maybe means this is the traffic I want to discard, or maybe not match our entries, something like this. So later, maybe the traffic cannot enter into the next step, maybe will be directly discarded. Like this example, IP access list standard 1. Of course, what's the meaning of these words? We will talk later. And the action is here. When you create one entry, and each one you can give a number, rule 10 and rule 20, and the action is permit or deny, and the protocol is IP, and what's the ACL range, 192, 168, or 1.0, and there is a wildcast. This one is different with the submask. When we talk about the submask, we say if the value mask is 1, that means you must be same with the destination IP address, right? With the prevent IP address. But if you use a 1, you can use, if it do become 0, you can use anything. So this is a mask. But the word mask is different. Later we will talk about the detail. So on each rule, at least one action we have to configure. Maybe it's permit, maybe it's deny. And then let's see the process. For example, first one in the inbound direction filtering working flow. When we receive the message, first you have to check whether to configure the inbound ACL packet filtering or not. If not, you can directly to do the next step, maybe to check your IP routing table. If yes, we have to match to first ACE because each ACE, like the example, we can have the number, right? And in each ACE, we can have the range to limit which message we want to select. And if we match the first ACE, and we will directly take the action. If the action is denied, the message will be discarded. If the action is permit, the message will be passed. And the next step is packets enter the forwarding process. We will check your IP routing table and then to do the encapsulation and forward the traffic out. But if first ACE is not the region is not cover the message, we will continue to match the second ACE. And also same, the second ACE we have the action. Maybe it's deny, maybe it's permit. If not match, we will continue until match the last one. If all the ACE we create cannot match the information, we will direct it to take the default ACE. If the default ACE is denied, we will discard it. If the default ACE is permit, also we can let the message pass through and do the next step. So this is the inbound function. But if you don't deploy the ACL in your network, no, that means we don't have any limitation for the traffic, so we can directly let pass and enter the next step. This is a process to receive the message, and the direction is inbound. But when we send the message out, on the outbound direction, we also have the workflow. Package send me out, and of course, we have to check the outbound direction we deploy the ACL or not. If yes, same compare the ACE, and if match, take the action, deny, discard. If permit, then we will pass, and finally the packets can be forwarded out successfully. If not, compare to the next step, deny or permit, until the last one, deny or permit. Of course, check the default ACE, default deny or default permit. Of course, if we don't deploy the out direction, the message will be directed to send me out. So there are two directions if we do the ACL. And about the process, we say the most important the first one is action to become deny or permit. The second one is the range. We have to use the correct range and then to match the message we want to select. And how to select the message? We will use a wildcard for the ACL, okay, for the control list. And the wildcard also is called the inverse mask. Usually is used to limit the IP address and also with the range together to describe the range of addresses. But the different one is in the wildcard mask, 0 means the corresponding bits need to be compared, but 1 means the bits don't need to be compared. So this one is different with the submask. And someone maybe say why we don't direct it to use a submask. Because in your submask, your number of 1 must continuous. You have to use a 1, 1, 1, 1, 1, and the rest to become 0. You cannot use 1, 0, 1, 0, 1, 0 to indicate the mask. But about the wildcard, it doesn't matter. The 0 can be not continue. It's okay, like 0, 1, 0, 1, 0, 1. So maybe in this formula, this format, you can use one word list cast and one IP address to indicate like IP address like 1.1, 3.1, 5.1, 6.1, 7.1, something like this. So this is the reason why we will use a wildcard. And the different wildcard, we will have different range. For example, if the IP address is same 192.168.0.1, The word card is 000255. That means the first 24 bits must be same. These first 24 bits must be 192.168.0, and the last 8 bits can be everything. So the meaning is compare only the first 24 bits. So the range will become 192.168.0.0 to 0.255. 255. So this is the range. But if we use this range, indicate the mask range will become 22. And 0 to 55 to 55, the mask will become 8. The range will only use the network address to indicate the range. If the webcast to become all 0, that means we only compare one IP address. This address must be 192.168.0.1. And all 250 means compare none of them. So we can use this IP address and this webcast to indicate everything, all the IP address. So in this scenario, if you use the webcast to become 250, the IP address to become 192 or 168.0.1, or use the IP address like 1.1.1.1, the same result. If you use a wildcard is this one. Okay. And the last one only compares the first 10 bits. Of course, in the example, we don't use a wildcard like 0.2.255. 255. If we use this wildcard to indicate a range, maybe we only indicate 2 segments, but they are not continuous. So that's why we will choose a wildcard to indicate the range of ACL. And the next part, let's see some basic configuration of the ACL. Usually, we will use the ACL 2 type, one for IP standard and another for IP extender. The IP standard ACL only matches the source IP address, so that's the meaning of the standard. So this configuration will be very easy, but pay attention. If we limit only the source IP address, that means all the traffic belonging to this source IP address will be discarded. But maybe you want to limit the source is PCA. If you directly use the standard ACL, that means all the traffic of PCA will be discarded. But if our requirement is PCA cannot visit PCB but can visit the PCC, in this scenario, that means some traffic of the source can be forwarded out successfully. In this scenario, you not only limit the source, but also have to limit some destination. So you have to use the IP extended ACL. About this part, we can match the source IP, destination IP, and also some layer 4 information like the TCP and UDP and some port number, something like this. And the keyword is extended. And of course, each ACL, we can have the number to indicate the ACL, and the number range is different. IP standard ACL, the range is like this, 1 to 99 and 1300 to 1999. And about this range, we only can match the information according to the source IP. And about the extended ACL, range is like this. We can limit more information. Besides them, also we have another limit, like according to the MAC address information, according to the first 8 bytes of the message, according to IPv6 information. But usually we will use the standard and extended, and this is a number. And of course, different vendor, we will design different IP number to indicate the standard or extended. Like Ruijie, we will use this range to indicate the IP standard ACL. And the configuration like this, standard ACL. Standard ACL can only match the source IP address, and the key configuration is IP ACL list standard 13, right? And we can permit, or maybe you can use the action is deny, but you can find the limitation only the source address, and maybe any. Any means all the message. And also you can use the value to become host, also indicate one IP address. And about the extended ACL, we can match lots of information of layer 3 and above, like layer 4, and also can match both source and destination IP address, like the IP access list extended. So these are the key point with configuration different, one for standard and another one for extended. And we use a value is 101. And about the permission, we can take a lot of information. This is an IP protocol. For example, if we permit 89, that means we can allow the OSPF packets pass through. If we allow the permit protocol to become like 6, that means we can allow all the TCP traffic pass through. And we also can use some EIGRP. GIE is special, maybe used for the VPN. ICMP, IGMP, something like this. So about the extended ACL, we can match more reasonable messages. And also we can give the name of the ACL for us to better understanding. For example, about the extended standard ACL, the range is from 1 to 99 and 1300 to 1999. And maybe you can directly create a standard ACL 1 to indicate your requirement. And also you can add some name like deny VLAN 10 to VLAN 30. It's better for us to understanding when you do the maintenance, right? If you only have the number, it's too difficult for us to know what's the meaning. Like this one, IP access list standard, and you can use this two coverage, and you also can directly to create the name. Why I know this belongs to the standard ACL? That's because the key words of the standard. And here is an example. Config ACL IP access list standard 99, and we have two rules, 10 and 20. Deny IP, and the destination is 192.168.1.0, and the range is 000. That means this range indicates only one address, right? The address is 192.168.1.0. You also can use the keywords host to indicate one IP address, and the address is 2.10. That means these two addresses cannot be forwarded out. Of course, and here is a question for you. If I receive the message and the source IP address is 1.1.1.1, what's the result? Can we forward the message out successfully or not? If you think it can, please write 1. If not, please write 2. According to this access layer, we will deny the source IP address 192.168.1.10. We also will deny the address of 192.168.2.10, right? So if we receive a message, the source is 1.1.1.1, what's the result? If you think we can forward successfully, please write down 1. If not, please write down 2. Can you show me some answer? No one answer? We say about these two entries, we will deny two source IP address, right? And also 1.1.1 coming, and we will match the rule 10 cannot match the coverage, and we will take to continue match the rule 20 also still cannot match. So this message will take the last rule, and by default the action is denied. So 1.1.1.1 also will be discarded. So in this scenario, if you only want to forbid the PC1 and PC2 cannot visit any destination, at last you have to add one rule to allow everything. Otherwise, you will discard everything. So this one we have to pay attention about this. The first one we create is the ACL type, standard or extended. And here is the standard ACL name to become 99. And the ACE action is denied. And the next step is the source IP address and where it is cast. Where the cast. And about the extended ACL, for example, now our requirement is block PC1 and PC2 from accessing the data stream of PC3. So we have to choose the extended ACL configuration, and the key point ACL type will become extended, and the number is 101. But the different one is we will take the action to become deny, also is IP, and the host 192.168.1.0 and to it the destination to become 3.10. And another one is 2.10 to wait 3.10 is denied. Also pay attention if the other traffic comes, cannot match these actions, cannot match these rules, we will take the default action to become denied. So pay attention in your ACL and you enable the ACL in your interface. Don't forget at least one rule to permit something. Otherwise, all the traffic will be discarded. Or maybe at last you can permit any to let every traffic pass through except this deny information. So pay attention about this part. Source IP and also get an IP address pool. And another one, if there are different access control requirements, we have to create multiple entries and then to meet the requirement. For example, we do not allow the PCs in VLAN 10, 192.168.1.10 to access all PCs. And we also not allow the VLAN 10 to visit the 5.0 segment. And only special PC in VLAN 10 to access all PC in the 3.0. And PC in VLAN 10 to access the TCP port number of 80 of 10.0.55, but the other port cannot. And other data stream released. So we now have to configure one ACL to meet these 5 requirements. And the configuration ideas, you have to determine to use which ACL, standard or extended. Or maybe in your requirement, you have to limit some MAC address information. You have to choose to use MAC address ACL. And we have to place the statements with the same format, the action, the string type, something like this. And when configure multiple statements according to the requirement, we have to make sure the configuration sequence, because we will compare the traffic from top to bottom, from the lowest number to highest number. So the sequence number also is very important. And here is the configuration. First, we have to select the extended ACL because we have lots of information to limit the source and the destination, although even some port number information. And then the first rule, we will permit the host 1.0 to visit the destination to become 3.0 and the word mask to become 0.0.0.255. This is the first one. And the second one denies the IP address to wait the 4.0, and denies the IP address to wait 5.0, and permits the TCP port number equal 8, and deny IP to wait the host number 10.0.5.5, and the rest of them can be forwarded out. So here we add a new one, permit IP any. So this one is very important because by the last, the default action is the deny. Okay, and about the sequence number, auto generate sequence number in 10-digit increment by default. Okay, so maybe you can directly in the ACL write down the rule, permit IP host, deny IP something, and deny IP. By default, the sequence number will become 10, 20, 30, 40, 50, 60. Okay, so this is a sequence number. Of course, you can directly to use the number like 1, 2, 3, 4, 5, 6. But suggestion, between the rule, you can exist several number here, because maybe in your future you will add a new requirement, and this requirement maybe need to be added between these numbers. But if you use 1, 2, 3, 4, 5, 6, you have to at least to delete some rules and add a new one. So this is a sequence number. If a new request is added, we have to block PC1, PC in VLAN 10, accessing the 6.0 segment. So the configuration you can add like 31, right? You can add 31. And before we permit the TCP information, we will take the message and match this information first. This command will be located here. And then the key point is, first you choose the correct ACL type, maybe standard, maybe some extended. And the second one, you also use a wordcast to limit the range, what's the traffic you want to select. And the very important one is where to apply it. If you create lots of ACL, but you don't apply it on the correct interface and the correct direction, maybe this traffic, this rule also cannot work. So when we choose application location, we also have some point we have to know. The first one, for example, we have lots of devices, application in the inbound or outbound direction of the interface. The data stream is coming in and out from the switch interface, and the configuration ACL need to be applied to this interface. For example, now we have some source IP address of the 192.168.1.10, right? If we want to deny or permit this traffic, we configure the range, and finally we have to apply it, and can be applied in outbound interface on these two switches to interface, and also you can be applied in inbound interface, the same result. For example, I have to discard this message. If we apply the message here, the traffic cannot enter. Also, we can apply the rule here, and the traffic cannot be forwarded out. So we will do the same result. Finally, the message cannot be with the target network. And also, if we locate it on here, the same result. Finally, the message cannot visit the target network. And those interface can be physical interface, also can be an SVW to be SVI to become the virtual interface of the VLAN. The direction of application is configured according to the contents of the ACL and also the direction of the data flow of the traffic. Like this one, we create IP XAL and use extended information. And about the 10, permit some information, deny, and the last one we can permit any. So in this scenario, what's the traffic should be, what's the application can be used? If the limitation is the standard, that means the traffic finally will be discarded. We have to limit the destination. We can nearly the destination because maybe the traffic will be discarded, and some correct destination also cannot be visited. And later I also will show you the example. One we show the nearly the source, one we show the nearly the destination. And what devices of ACL should be configured? And the principle is, if we need to control the traffic within the VLAN, the message should be configured on the access switch. Otherwise, if the traffic should be forwarded between different VLANs, we have to configure the ACL on the aggregation switch, at least on the gateway layer, because on the aggregation switch, you can have lots of VLAN. Of course, about the second requirement, you also can configure on access switch, but lots of access switch you have to do the configuration. So now if we have a ACL, this is extended ACL. We deny the traffic host 192.1.10 to 1.20. PCA cannot visit PCB and the other traffic can be forwarded out. And because these two addresses located in the same VLAN, so we can add the interface. One places in distribute switch, and another one is applied to the interface on the access switch. B is right, because if A and B want to wait with each other, the traffic link is like here. We will not forward the traffic to the distribute switch. We can directly forward the traffic to access switch. Okay, so this is a configuration and select the places. But if we require the VLAN 10 cannot visit the VLAN 20 and 20 also cannot visit VLAN 40, if this requirement and the ACL is configured on the access switch, we have to configure the ACL here and also here and also here. Lots of access switch if they covers the VLAN 10, VLAN 20, and VLAN 30, VLAN 40. So in this scenario, we can apply the ACL on the distribute switch and on the gateway interface. Like this ACL, we deny the IP, and another ACL, we will deny the segment from 2 to 4. And on the distribute switch, enter the enter the SVI interface, we can apply the traffic in. When I receive the message from VLAN 10, I will direct it to discard it. So this is the second application. Configure the ACL under the SVI of the gateway switch. And the third one is the ACL applied on the device as approximate to the source or to the destination. If some traffic should be discarded, we hope we can discard as soon as possible because this traffic finally cannot visit the destination. One more devices, one more link to forward the traffic. There is a waste. So we hope we can discard the traffic as soon as possible, but some normal traffic you cannot discard. So like this topology, here is a PCA and PCB, right? They located in different segments. And now we have to consider the type of ACL as well as the actual application and also the configuration. About the standard ACL, we suggest to approximate to the destination because about the standard ACL, we will directly discard the source IP address. If you apply the standard ACL in the device, all the traffic from this source will be discarded. So if here now we configure the ACL, deny 192.168.1.0, this segment cannot be forwarded out. And we apply the traffic here. Use the standard ACL and we will configure here. And the result is PCA cannot visit PCB, right? But if here we have the PCC, we have PCC. PCA still convert to the PCC, and this is a normal traffic. But if you apply the ACL here, PCA to wait PCC, PCA to wait PCB, all the traffic from the source 192.168.1.0 from this source. Okay, so the normal traffic to wait PCC also will be discarded. This is a reason why we suggest the standard ACL is approximately to the destination address. Otherwise, maybe some normal traffic will be discarded. And another one, for the extended ACL, we suggest to proximity to the source of the message. Why we can take it to the source of the message? For example, the range is deny 192.168.1.0 to the destination 10.1.1.0, right? And then we can match to allocate the information here. And we will allocate on these devices. And at the beginning, the message PCA to wait PCB, we can match this information, we will discard it. Otherwise, if you send out and you apply here, this link will be transferred some message, but this message cannot be forwarded out. So this is the advantage. And if now PCA want to wait the PCC here, can we discard it or not? If PCA to wait PCC, we match the rule of 10, we cannot match the range. So we will continue to match the range of 20. Finally, the manager will be permitted to forward out. So about the extended ACL, because we can match the detailed information of the message, so suggest to approximate to the source as soon as possible. And another one, for extended ACL, you can also configure them on the message destination devices if you want to control them centrally. For example, now about the ACL, we want to deny PCA to wait PCB, and we also want to deny the PCC to wait the PCB. In this scenario, we can apply the ACL here to control A and C to access the PCB, right? And if you apply here, or maybe the upper switch here, some other traffic want to wait the PC destination also will be discarded. Or maybe you configure apply the ACL on the first switch. You also have to add the same configuration on this switch again, because lots of the different devices will receive this message match the same requirement. So in this scenario, maybe you can directly to apply on the destination devices, and you only add one ACL is enough. So this is the application. And here is a question of ACL. What is the standard ACL series number range? The standard range is, can you show me the correct answer? Which answer should be correct? A and B? A and C, yes. The standard ACL is A and C, right? No boy. Boy should be the extended ACL. So the range is a little difficult to remember because they are not continuous. And it doesn't matter. When you do the configuration, you can enter the question and to get the remainder and directly to give the answer. To do the configuration, it doesn't matter. But you have to remember the keywords is IP, access list, standard, and extended. But the number doesn't matter. So this is the part of the ACL. right? We can use ACL to like standard ACL and extended ACL. And we can use different information to indicate the requirement. But the standard ACL only can match the source. The extended ACL can match the source and destination IP address and some port information and also some protocol number, something like this. Of course, in our network, we also can configure the ACL based on time. Some requirement, for example, in your working time, from 9 o'clock a.m. to 18 o'clock p.m., you cannot visit the internet. Then you can limit the range. And this part we also call is time-based ACL, but we not talk about here. We have to understand what's the meaning of standard ACL and extended ACL. So about the ACL, do you have any questions we want to discuss together? If not, maybe we will talk about the last part of the net.